So you should have just done some practice with graphing some parabolas that were set up in an equation form, or maybe finding equations of parabolas based on information given to you, basically using stuff that we talked about in the previous video. So now we're going to do one last technique, and it involves completing the square. So what I'd like you to do right now is in the moment, pause this video and fill in what you think goes in there to complete the square on each of these little spots. So actually, maybe I'll do one. So say I had x squared minus 6x equals. So say I wanted to complete the square. Well, I would take the 6, I would take half of it, which is 3, I guess negative 3, and then square it and get plus 9. So I'd like you to do that for these other two. Go ahead and hit pause. So you should have gotten plus 16, once again plus 16, and then this one plus 4, and this one plus 20 over 2 is 10, squared is 100. Now what I'd like you to do is write these out in factored form. So I will do my one on the bottom. So this guy is going to factor to x minus 3 squared. Before you go ahead and do it, I just want to point out that the reason why we call it completing the square is because it's like basically I got this polynomial thing right here, and I want to put a number here, complete it, so that I can then factor it into something that's perfectly squared like this. So go ahead and do that for these guys, and hit pause first. So boom, that's what you should have gotten. If you're having trouble with that, you should probably go back and kind of review it. I'm not going to take time in this video to teach a whole lot of it, but it's kind of like a little warm-up for what we're about to do. So, boom, new problem. We have a parabola here. You should see that it's going to be an x squared parabola. When I have parabolas like this, there's actually lots of ways to graph these things. You know, we talked about a lot of ways to graph these in first semester, but when I say label all the parts, specifically in this conics unit and stuff like that, I mean label the focus and the directrix. Sorry, I might have stopped there. Label the focus and the directrix, and the vertex, and you'll see all the parts for some of the other conics that we'll talk about will encompass other ideas. But so I can't just use old school methods. I need to get it in the form of, actually let me write it. So I need to get it in one of those two red forms right there. So you should be able to look at this, and one of those two red forms will work and the other one won't. So is it this one or is it this one? Well, since we have an x squared here, you know, I'm going to get an x minus h squared. So this is going to be an x squared parabola, so I'm going to be stuck with one of these. Notice this is x minus something squared, right? So if I go back to what we just did, x minus something squared, x minus something squared, x plus something, which is x minus a negative something squared, you know, boom, boom, boom. These guys, the reason why we need to complete the square is because we need to take this thing right here and turn it into something that looks like this. So let's go through these steps together. The first thing that I'm going to do is rewrite it as y equals x squared minus 4x. I'm going to put this in parentheses and then write minus 8 like that. Now I'm going to fill in right here and then balance right here, completing the square. So let me give myself some space with this. So the question now is, what do I add to complete the square on a minus 4? Well, divide by 2 and square. You should get plus 4. Now, the key here is that I want this equation and this equation to be equivalent. I want them to say the exact same thing. So I took this equation and wrote it all in green, and then this red thing showed up. So since I added that 4, this equation is no longer the same as that equation. So what I can do is I added a 4. If I take 4 away out here, then it'll make this equation exactly the same as that one, or equivalent, I should say. Means the same thing. So if I write minus 4 here, then it's going to be the same as the previous one. Notice add 4 here, subtract 4 here. Things will get a little funky as we move along in terms of rules for this or ideas around this, so I'm not going to kind of say anything other than working my way through it logically at this point. So let's continue on. I have y equals, open parentheses, squared. Hold on. I am gonna, yeah, it's not too late to change. I'm gonna change this to a +8. I'm just gonna change this to a +8. That's the way I meant to originally do the problem. I'm not gonna go back and redo the whole video. And all it does is change those two little pieces. So go ahead and change those pieces on your paper, and just imagine that that's what we started with and we rolled into this. Same idea we just talked about. Anyway, so here I'm going to go and make it, I want to make it look like this, right? Actually, so let's just steal, can I zoom out enough? Not really. So I want to take this guy, which we can't quite see over here, is one of these things over here that we worked on, and turn it into one like this. So I want to factor it. So it's going to factor down to x minus 2 squared. And then these guys over here, I'm going to do 8 minus 4, and that gives me minus 4 like that. So notice it's almost in this form here. I just need to take this guy, move it over there, and you'll see how it's in that form. I get y plus 4, put in parentheses, equals x minus 2 squared. Now, it doesn't quite look like it's in this form, but it actually is. Maybe I'll switch the sides that things are on. So this is the same as saying x minus 2 squared equals y plus 4. Now notice, this side is pretty obviously in that form. X minus 2 squared, x minus 8 squared. This guy just says y plus 4. There's no 4a there. Well, if I had an a equal to 1/4, then that would give me a coefficient of 1 right here. And that's actually what the a value is here. So, actually, what we're going to do is now go ahead and graph this thing. So, I'll go to black. I've got a grid that I'm going to sketch in. I know that my vertex is at, 2, -4. So I'm going to go 1, 2, 1, 2, 3, 4. Come on now. I hope you caught my error. You probably did. You've been wondering what's wrong with me the whole time. +4. Sorry, this is happening twice in this video. And then erase, -4, -4. My apologies that I have trouble with math. Anyway, so let's move on from here. I get 1, 2, 3, 4. My vertex is going to be at 2, +4, like that. So I'm going to go and put a dot there. Now it's a x squared parabola. The a value is 1/4. It's positive, so that means that it opens up. So I'm going to go ahead and draw it as it opens up like this. And now I'm just going to put a dot in here for the focus, knowing that I'm not doing a very good job of drawing it to scale. But a equals 1/4 means that the focus, and let me label that as F, is 1/4 above the vertex. So what that does is puts my focus at same x value, and then 4.25. And then the last thing is I'm going to draw my directrix like this. It's going to be really close to there. I'm going to say D, and that's a y equals equation, and it's a quarter below this thing, so I go below the 4, down by 0.25, which takes me to 3.75. And I think that all this is correct at this point. So you have to do lots of stuff where you complete the square like this, and it seems kind of silly with parabolas, in all honesty, because we already know how to graph parabolas, and why would I complete the square like this if I have other ways to do it? But as we move along into the other 3 conics that we're going to do, you'll see that the completing the square helps out a whole lot. So this is a good way to get ready for it without having it be too complicated. So you want to make sure you're good at this before we move on.